Okay, now we have a big problem in here. What is that? This capacitor charge, we have some voltage. In suddenly power failure, if you take the amplifier, if I made them this amplifier, if I made this circuit and if I put that amplifier, when amplifier is working, suddenly power had failure. So then it's an instant time. If the power is failure, then after suddenly it again came. So we have a big problem. Why? Because that instant time, this capacitor also charged to this voltage drop. General voltage in here Vz, and here also have 0.6 volt. This voltage drop, if we take as if we take Vz equals 12 volt, then also in here 12.6 volts. 12.6 volt is also in here. Why? Because this circuit, you know, NPN transistors, this transistor, if we bias this one, is also pulling like microampere time, that much current, microampere, that much current. So it cannot discharge capacitor as soon as. So if the suddenly it came, the relay is also may turn on, and that give the noise. So we had to use another method. What is that? If I have some method to discharge this capacitor, then I can that instant time it's automatically short circuited, that then capacitor charge can get some low value, zero value. So what I'm trying to do in here, you know, I think before I told that there are some equations for discharging of the capacitor voltage. So if I write like that one, what I am going to do, if we want to discharge this capacitor, I put a resistor to here like this. What happened after the power had failure? This power had failure now. Then there's no connection. This is the very if I take this as RC, then what happened? The capacitor may get out of the current, and he flowing this path. This path is flowing the current. Then it was totally destroyed by this resistor. So this is the basic method you can use discharging of the capacitor. In here, capacitor discharging, there have some equation. In capacitor equation, this equation we can rewrite discharging equation. Discharging. What is the equation is? In here I take as that voltage as V dash. V dash equals in here voltage in up to charge Vs times e to the power minus T over Rc. This is the basic equation for this circuit discharging of the resistor. In here R dash is here, R dash C is the capacitor value, this is R dash value. Then we can calculate discharging time. This T is a discharging time. So this is the basic circuit I can use. So I will rearrange this circuit. So in here what happened? If the power failure, very fastly discharge this capacitor. But there I have some any other issue. What is that? If I take some think like this R also is equal to R. If we take this R equals to this R, then what happen? If I provide in here, if I provide 2 volts, this resistor may get 6 volt, and this resistor may get 6 volt. In here I am using 12 volts in a diode. So I can use 12. I can use some. I take as 13 volts. No problem. If I take that, no, I get 14 volts. It's easy to apply. In here 7 volts, and in here 7 volts drop, voltage drop. Then in here also have 7 volt drops. What is happening? This first time this capacitor is pulling the current, there's no path to way, current is pulling this capacitor, no problem. Then after, according to up to charge 7 volts, this also fixed. But this is in here we need 12.6 volt to conduct. 12.6 volt to conduct to this voltage. So that's why I use a 14 volt in here. 13 volts near to 12.6 volt. No, there's no problem. But so 12.6 volt need, then 7 volts need. If the R is equal, somehow so this there are problem. Then voltage is not much enough. So we had to use another method to do this one. And what is the method is, if we have some method to cut off the if the power is on, then capacitor may get to 12.6 volt, and if suddenly it's off, then this connection also connected that time. If the power failure, this switch is also closed. If the power come, this switch also open, then current going to this one, and there's no problem. If the power failure instant time, this switch may get turned on, then we can flow in that current and discharge the capacitor, no problem. So we have to use another switching method to this one. To do that, we cannot use manually, so we have to automated one. So we have to use some switch to this in here. So what I'm going to do, we cannot use transistor. Same problem is there, and we had to use some like this type of transistor. So very easy method in there. Yeah, I'm not going to like this circuit. I'm going to another something simple thing. What is I'm going to do? In here, I put a diode. Input time in a diode. What happens? If the current is come, this one may get current, charge the capacitor very fastly, pull the current to capacitor. Then there's no going here, current. There's no going here current. It's only going to here. Then after power failure, this also going like this, but the same issue is there. Why? Because there I have 0.7 volt drop if we take a silicon diode in R. And what is the equation for this voltage as? If we take R and if we take R, we can say what is the voltage actually. So here we take as VR drop, here we take as VR drop. Then what is 2 VR drop plus 0.7 volt is the total voltage on to according to VS. So if I want to find the voltage in here, apply 14 volt. Then what happen? Come to here 13.3 volts. Then divide by 2. Then I can get VR as VR is 6.55. I think 55. 12. 30. No, 55 is not in here. Let's assume I think 12.675. If I take 13.3 divided by 2, what is the answer? Is 6.65 volt. 6.65 volts. If the in here same case is there, 12.6 volt we needed, but in here 6.65 volts. So very big issue. What we do? Yeah, I have another method. Same thing. What I'm going to do? I apply this one. I apply this into here. This I apply to this junction. Now what happens? This is also plus VCC 14 volt. This is also plus 14 volts. What happened? There's no current going up to this capacitor fully charged to this 12.6 volt, no problem. then after there's no going to current into here. Why? Because same voltage, this voltage also high, so current pulling this voltage is 14 volt, in here 12.6 volts. What happened? The voltage difference is across forward biases, reverse biases to diode. So there's no current going into here. So easily this method is very perfect one. So then after, now in other case, if the power is shut down, what happened? This voltage and this point also lost it. Then what happened? Here up to 12.6 volt charges. Then what happened? Then this diode is conduct the current because it's forward bias. So no problem. The current was pulling up to here. Then come and go through this circuit. So actually this is better method to in thumb protection circuit. It is this method we call as a fast recovery. Why? Because fast recovery method, thumb protection circuit, it's also instant time to discharge this one. So I think this is the final circuit. If I draw some clear diagram, 1 minute to give me. Okay, I put into here. What I'm going to do. So this is VSAT, this is silicon diode, so this is R dash, this is R, and this is C. So in here I can connect also into here, no problem. So what happened? This is the final circuit in thumb protection circuit. So I think it's very simple circuit, so very easy. Okay, let's go and do the practicals.